I aim to go through recurrent neural networks. So I will explain first of all a little bit theoretically, and after that we will try to use Python code, how to we can implement this theoretical background into real life problem, right? And this will be predicting that we will some get text tweets from normal tweets, and after according to these tweets we will try to predict the emoji that the person will use. For example, if the tweet is about something sad, the emotion will be a sad emoji, right? And we will try to create a recurrent neural network model to predict according to the words of the tweets and what kind of emoji we will estimate. Yes, as you have gone through, the recurrent neural networks is basically used for speech recognition, language modeling, translation, sometimes image captioning, and there is a need for recurrent neural networks because normal neural networks sometimes does not answer some of the questions that the recurrent neural networks address. For example, if we want a computer to predict, for example, a poet, which other words will come, or we have a Chinese text, we want to translate this Chinese words into English or Norwegian. Normal neural networks cannot tackle these kinds of problems because for these kinds of problems we need to a good memory that after learning each word the computer, the algorithm needs have a good memory and also good connection between these kinds of words, and after that it will predict what kind of translation it will be according to the inputs we get, right? um, as I said, computers have not like humans, they don't have a persistence in the memory when it comes to neural networks. uh, This is a very good, very big shortcoming of traditional neural networks. But here you can see a normal standard loop of a recurrent neural network. These are our inputs, right? And this hash represent our outputs of the recurrent neural network. And it will have a loop inside this network, and after that according to the input, and after that it will give us an output. This is a just single neural network, just single, and just single, we can say just single neural networks, but in real life we have sometimes thousands of them, as you can see here. And um, there is a chunk of neural network inside recurrent neural networks, and every chunk will have the responsibility to deal with a specific kind of problem. For example, memorizing a word, and after that, according to this word, predicting the next coming word. Every chunk of the network has this responsibility. And for example, if we look at this picture, it seems a little bit complicated for you. As you can see, we have x0, x1, x2, or x1000 maybe or more. According to the words, for example, we are talking about translation, right? According to the translation, we made thousands of words. Every word will be represented as an input for our neural network. But inside these chunks of networks, every chunk of network contains a normal artificial neural network like this one. Maybe from the previous picture, we see a very very simple version, but this chunk of network is that contains these kinds of a huge artificial neural network also. But the difference is normal artificial neural networks can contain more than one hidden layer, but this recurrent neural network, every single of them just include one single hidden layer. Input, we have inputs and input layer, and after that we have a just single hidden layer, and we get the output. So we can think recurrent neural network a much more complicated version of the normal artificial neural networks, because it also includes normal neural networks, but it's also uh, every it also includes recurrent version. For example, information come here to go after that, but every chunk uh, goes a lot of job inside itself, like normal artificial neural networks, right? And but this was a good model for recurrent neural networks, as we can see here. But sometimes, for example, if I, for example, create a sentence, the clause are in the, for example, what is the end of the sentence? Normally we predict that kind, right? This is very simple, and normal recurrent neural networks can easily predict, according to this sequence of the sentence, the last word should be sky. But for example, when it gets more complicated, like I grew up in Norway, I speak fluently Norwegian, right? So the sentence is a little bit complicated, right? So after predicting for example, the name of the country, Norway, we also expect to predict Norwegian people, people in Norway uh, can speak Norwegian. So there is another task the computer has to deal with. It is a little bit complicated, and sometimes we get some um, emotional sentences inside a normal sentences. So when it gets a little bit complicated, normal recurrent neural networks has got some drawbacks. So therefore, in 1991, if I can remember correctly, there has been emerged a very good solution for this long-term dependency problem. For example, in a simplified way, the normal recurrent neural networks can predict very good, but when it comes a little bit complicated verbs or translations, it has some problems, and therefore the normal recurrent neural networks need much more complicated objectives to tackle these kinds of complicated problems. This is the reason of the emergence of long, short-term memory networks. Um, in a normal sense, now you see a normal standardized recurrent neural networks. It only includes one single layer inside itself. As I said before, there is only one hidden layer, and this is normally it is accepted as this tanh function, uh, tangent, there is a specific name for this, hyperbolic tangent function, this function, but there's only one single layer. But when it comes to complicated problems, complicated translation or voice recognitions, one single layer is not enough to tackle this problem. Therefore, uh, they developed a little bit complicated, but a very good, in a very good mentality. This this new kind of version, um, long short-term memory network, or in short terms, LSTM. We can say LSTM. Uh, this is normal, basic, recurrent neural networks with only one single layer. But when it comes to these LSTM networks, as you can see, this this one also includes the same complicated operation inside itself, but in this picture we only see one of them in order to focus single one. But all of these, the next layers also includes the same complex operation inside itself. As I said, they also includes an artificial neural network inside itself. So I will explain what is the difference between these simplified recurrent neural networks and LSTM. What is the difference? Why LSTM performs much more better when we encounter complicated problems. Um, this is, for example, as you can see, there are a lot of layers inside LSTM. Every single network, we can name that each of them as a network. Each of them, as you can see, there are a segment function we can see as cross symbol, right? We have another sigmoid function, and we see as cross, and also tangent function. Normal recurrent neural networks includes only tangent, this hyperbolic tangent function. But as you can see, a normal LSTM neural network, recurrent neural network, includes 4 different functionality. I will say what this functionality will, how each of them works. For example, the first one, as you can see, there is a segment function, but we see a cross symbol, right? This means, for example, if an information comes inside our neural network, maybe you remember a segment function just outputs 1 or 0, right? 1 means it is okay. 0 means in this recurrent neural recurrent neural networks, please forget this one, right? This is, we can say that this is a gate. Each of these function as a gatekeepers in order to uh, enable a word to go to the next layer or not. For example, we can say that if a sentence, how can we say this one? Yes, if the neural networks accept this word, for example, it will, okay, just go to the next layer, but it will not accept this one according to the operation inside itself. It will forget this word. So the entire neural network will get rid of this burden, right? Uh, and when it comes to other layers, we are now dealing with this one. This is a forget layer, right? Uh, these are our inputs, X. These are the inputs coming from the next layer, right? We combine these ones, and after that, first we decide, the network decides, we will forget this word or we will use this word, right? And after that, there comes another layer. We can see another sigmoid function and hyperbolic tangent function, right? Um, for example, when we are creating a sentence, when we want to add the gender, for example, let's say that our object is our person is named Nikolai, for example. And for the coming next sentence, in order to every time repeat Nikolai, Nikolai, we want to use he or han, whatever language we use, right? And this sigmoid function gives us this complexity. So for the next layer, it will create, for example, instead of using every time Nikolai, for the next sentence, as you can see, there is a add plus sign here, and it will create, okay, Nikolai is a name of a man, so we have to use he instead of she, and there is no need every time Nikolai, Nikolai. This is absurd for a normal conversation, so or normal translation. And this second layer will accept, instead of Nikolai, we'll add he, and you can see as plus sign, and it will add it into the memory of this recurrent neural network. And so Nikolai will be represented for the next coming sentences, for the next coming translation, he. So this is, for example, the responsibility is this. We are going on a simple example, but according to the problem we tackle with, the responsibility of this line is maybe may differ itself. Okay, but meaning this responsibility is just adding this new learned learned outcome into the next layer, into our recurrent neural networks memory. Um, you can see our weights and our biases. Okay, and this is as I said, the next layer, the next layer inside every single chunk of recurrent neural network. Yes, and after that, uh, there comes another sigmoid function and hyperbolic tangent function, and the outcome will be represented from the output of this layer, from this output of this operation. Um, yes, for example, we can say that um, if, for example, we are talking about a person, for example, this layer may be responsible for these persons are singular or plural. For example, if we are talking about people, and the next coming sentence we have to create they, right? So this layer, for example, is responsible of this plurality of singularity of the sentence of the subject, right? So, and after that, this hyperbolic tangent function will create the outcome of this just single chunk of recurrent neural network. Um, this is one of the hardest topic of these neural networks. Um, as I said, when we summarize, we can say that uh, there is a chunk of networks inside each of recurrent neural networks, right? And every chunk of networks includes a single hidden layer with a single hidden layer, an artificial normal neural network. Every one of them has this one. This layer, this chunk of network includes every one of them. For example, in the memory of the computer, maybe we have 100,000 words, and every single one of them represent one word, for example. And inside every single chunk of network, they also include and this normal neural network with a lot of mathematical operation inside itself, but with only single layer. So um, therefore, as you can see, I have introduced you the LSTM. The LSTM make our algorithm to tackle with the much more complex problems, right? For example, when it comes to translation, the gender is important. The plural, is someone is plural or not, is important, right? But you should have keep in mind that when, for example, when we are talking about um, translation, right, from, for example, Chinese into Norwegian, uh, don't think that these words is represented in this algorithm as a word itself. All of the words will be represented as numbers. So therefore, these algorithms can tackle mathematical operations. The computer will not understand, for example, Nikolai or Frudo or Sebastian or something other name or gender or plurality or singularity, nothing else. But all of these words will be represented in numbers, and therefore the computer will keep these words inside its algorithm as a numbers, and according to numbers, the algorithm has the ability to make mathematical operations, and in order to tackle the problems we want to deal with, right? And this is a little bit theoretical information about how it works, but I personally believe that this theoretical information which should be strengthened by using a real life example, and therefore we will continue to some Python codes in order to understand with a real life example. As I said, our example is tweets, and according to the content of the tweets, we will predict the emoji someone will use, right? For example, you are writing a tweet and you are very happy. Will you use a happy emoji or a sadness emoji, right? We will predict according to these texts. So in order to do this Python code, uh, actually you can use Jupyter Notebook. You can follow on me, or main I use Kaggle. Um, so this makes me get rid of installing a lot of things inside itself. I can find a lot of necessary TensorFlow or Keras libraries embedded inside the Kaggle. So you can use normal Jupyter Notebook or Kaggle. It's up to you. Let's simply open a new Kaggle document, right? Yes, let's go kaggle.com. I will create a new notebook for you when I click code, but you can, as I said, you can use normal Jupyter Notebook. If you find my pace a little bit faster or something like, please let me know it. New notebook. Yes, let's name this one the current neural networks. Yes. Let's run the first line because we are importing NumPy pandas as a standard library we want to use. And after that, we will install pip. I'm sorry, pip install. This will install NLP, natural language processing, because we will deal with the words and sentences. So we will import this one. Before importing this one, we have to install into our computer. When you use Kaggle, it will only download this one for this single notebook, not the entire one. So it will not make a lot of storage problem for you. So let's use pip install NLP. You can use the same command if you use the notebook, pip install NLP, the same code from the um, prompt command or condas prompt command. Yes, as you can see, successfully installed, right? And now after installing, we will import this library, import NLP. Let's check and run this coding line. Okay. And then inside this library, there is I will assign the result into that data variable. There is that data set, you can work on it. One of them is emotion data set, and NLP load data set, emotion, right? Let's run this one. Now, inside this NLP, it's a very big library. There is a lot of data sets. You can work on it. One of them is emotion data set, which means the predicting emotions according to tweets itself. Yes. Um, as you can see inside this data set, we have a training set, we have a validation data set, we have a test data set, right? So, for example, we can go through what these ones includes. Uh, this is our variable name, right? As you can see, it's a we can for example get the results of the train data set, data.train. We can reach the result, right? Inside this training data set, as you can see, there are features. One of them is text, the other one is labels. For example, if you write here text, because we will want to get the, as you can see, these are the tweets, right? And if you, for example, write here labels, you will see the labels. Yes, inside this one. Let's assign this one training data set, or training data set. And for validation, let's copy this one and create a name, variable name, validation. And from our entire data set, let's choose the validation section and assign this validation into our validation variable. And let's do the same thing for the test email, test tweets, data that test, right? Let's run this one. Now we have assigned all of these information for training data set into training variable, for validation into validation, and for test into test, right? And for example, we can easily, for example, let's see the text of the training set. You can see the text, all of the text inside. There are a lot of text. For example, let's see the first one. Let's see the first tweet. This is the first tweet of our training test. I didn't feel humiliated. But how this one is represented by or labeled as an emoji by using emoji. We can choose, let's copy this one, because instead of text, we will just choose the labels. As you can see, there is a, inside the data set, there is a text section as a dictionary, and also there is a labels. Labels is represent the type of emoji according to text. Text means all of the tweets, including all the text of the tweets. Yes, let's say that label 0. Yes, as you can see, the first text of our training data sets is this: I didn't feel humiliated, and it is represented by an emoji of sadness, right? We can learn a lot of others if you want. Let's call this one. Just we need to, this is the second one. For example, let's get the second text. As you can see, I can go from feeling so hopeless, and this one is represented. We can also learn, just label not 0, 1, for example. This one is represented also sadness. Okay, if someone write a tweet something like that, this is at the end of this tweet, they use sadness emoji. This means that. Okay. Now we have imported our data and we have assigned it this into three data sets. There were three data sets. Some of them are training data sets, and some of them are uh, validation data sets. We will use all of them, and also test data sets, right? Yes. Let's do. Okay. As you can see, in order to reach the tweets, we use just inside inside these close brackets. We just write takes that as a key name, and also labels in order to reach the labels of this tweet, right? Let's create a function instead of every time to reach the text or the labels of this tweet. We can create a very simple function in order to get these data. Let's say name that get tweet. Um, let's assign this one tweets, not train, tweets, right? Um, we will assign the results, right? Let's create this one as a list, Python list. X takes the, because I will do a for loop inside this one for x in tweets. This is another way of creating for loops. You can see also like this one for x in tweets. It will create a for loop inside all of the tweets, and for each single one, each will assign takes that inside this tweet. Okay. Instead of using this one, I'm using a very simple one, and also we will assign the labels. Let's copy, and instead of for every single loop, we will get the label, right? Label section from the tools and assign this one into label. Yes. And let's return. Tweet or variable name and label. Okay. Now our function is ready, which means that, for example, we can get, let's assign the tweets and label, tweets and labels. Our function will go through the entire data set and get all the tweets text, and also assign these text inside the tweets variable, and assign each label inside the label variable. And now I am creating new variables, tweets and labels, which will represent all the tweets inside the data set, also all the labels inside the data set, right? And get tweet, I will use my function. This function will go to my training data set and use this function and assign each tweet inside tweets variable, and labels inside the labels variable, right? Let's see the results. As you can see, we have gotten all of the tweets from our training data set by using very simple function, and assigned all of them inside the tweets variable, and it's a dictionary of strings, right? That includes all of the tweets. And we can do the same things. For example, let's do this one for the let's print out the labels, right? We also do not here. Let's get our labels. As you can see, these are the labels from the first one to the end one: sadness, sadness, anger, love, anger, sadness, surprise, fear, joy, love, something like that. Okay, for example, we can simply print the result. Let's Let's print tweet, the first tweet and the first label, right? In order to make a and labels 0. Let's print this one. As you can see, this means our function, our self-create function works good. Now we get the first tweet and it is a corresponding label as sadness. Okay. We will do the same things we can do the same thing for the validation data, because we will use also validation data from our data set. Okay. Let's name this one validation tips and validation labels. Okay, we will use our get tweet function. As you can remember, it will return the tweets. The first one, it returns the name tweets, and the second one is the labels, right? So there are two outcomes of my function. So the first outcome will be assigned my variable, val tweets variable. You can name whatever you like, and the labels, the second outcome of my tweet function, will be assigned to the second one. Okay, and for this one, because we have a validation data set which is represented as a validation, let's look at for example, the first tweet of the validation data set. That's 0. This is the first tweet of our validation data, right? Okay, we can do, for test set, we will do the same operations in the end of this tutorial in order to test it. And is there any question to this point? Nicola, it seems you are alone, right?
It seems so, yeah.
Okay. It's very good, and you are very excited on coding, and so you have I get a very good shine from you. This is the way. This is the way.
I kind of prefer the Python approach as to learning this mostly.
Yes, in order to get deeper understanding for your future, I think this is the best one. I also advise every time you should begin as soon as possible, not delay this learning Python code for the next coming semesters. It will not get easier for the coming. You will learn the same things. Yes. If you ask any question, I've also published this tutorial from the Canvas, but not important. But now the second, now we have from this part, we have just imported our data and separated into 3 data sets, right? Because our normal data set includes training one and validation data and also test data. Now we have separated each of them and assigned to different variables name in order to use in the future. Mainly, I will deal with the training and validation data set in order to train our algorithm, recurrent neural network algorithm. Therefore, we have begun to this point separating all of these ones into variables in order to use them in the future. Yes. Now the second step is, as I said before, normal machine learning algorithm will not understand the words. So we need to transform these words or these tweets inside the data into numbers, right? But we will not do it personally because there are very good libraries inside TensorFlow which have already written the developers. One of them is let's import from TensorFlow keras pre-processing, yes, text. Scikit-learn also has pre-processing, which means we are now pre-process the data, right? And inside the pre-processing sub-library, there is a text sub-library, which includes all of the functions that we want to deal with the text. So tweets are text, so we are using this one. We will import tokenizer. Yeah, I'm sorry, tokenizer. Yes. After importing a function from a library, any of them, we are create an object of it, right? Let's name this object tokenizer. Let's create an instance of this one. Copy tokenizer, right? So this tokenizer has a lot of words that has been assigned into the numbers. They have this tokenizer function includes most commonly 10,000 words, which have been represented by the numbers. So we will use inside num. This is a parameter inside this function. Number of words is 10,000, which means that it will use in order to in order to assign numbers to the words inside our tweets. It will use these previously designed most common words, and if it cannot find the word inside a tweet, and we will use token. This one is a unknown words, right? Let's do it. We'll write it. Okay. If this tokenizer object cannot find the words, that is, it is pre-designed library. If it cannot transform into the numbers, it will assign unknown this variable name. So it will label as unknown. So mainly normal language processing, this 10,000 word is enough for assigning numbers. So we will use these words inside of assigning for numbers for ourselves every time. We are just using previously assigned and created library. Yes. Let's run this code. In order to transform this one, we will just tokenizer dot fit. Now we are using function inside method inside this function. Fit on sequences means which it will now take the words from our data and go inside its own dictionary, is 10,000 words. If it finds the numbers inside these 10,000 words, it will assign the corresponding numerical value. If it cannot find, and it will assign unknown words. Okay, so we are using this one, and let's assign our tweets, right? These are tweets from our training data set. Let's use this one. Yes. For example, let's how in order to see how it transform words into numbers, let's see from the first tweet, the result from first tweet, right? Yes, sequence, that one. Okay, actually, this coding is still running, so it takes time in order. Now this command, this code we have written here, the machine tried to transform all of these tweets into the numbers, so it may a little bit take time. Maybe we have to wait. Let's do that one. Let's do that one. Is there any question? No. Let's run all of them. Why is it tokenizer? Is there something else wrong?
Is the tokenizer supposed to output by default with the fit on sequences function?
Can you ask again, Nikolai?
The function fit on sequences.
Yes.
Is that function supposed to output by default?
Yes, by default. Yes, because, for example, I is represented, I don't know, maybe 50 as a number. So it will use these default numbers inside itself. I have to restart the kernel because let's run all of them. It took a lot of time. As you can see, the CPU is very busy now. Let's wait to see the results. So it works here. Tokenizer. I'm sorry. This is a fail function I use. Test on sequence, not sequence. Text to. First, we will fit. Yes, without fitting, we try to transform the data. It's not possible. So first of all, this algorithm, this object tokenizer should see what kinds of data we have. Yes, our tweets. It's right. And after that, and now it has fitted. And after that, we will use the same tokenizer dot text to sequences. Yes, this function. Let's do it. For example, let's do all of the tweets. Now it's working. As you can see, this is our first tweet. For example, it is represented by these numbers because I will show you what our first tweet includes in our training set, right? Yes, as you can see, there are 4 words. This tweet includes 4 words, and for example, I is represented by number 2, and didn't represented by number is 139, and field represented by number 3, and humiliated represented by number 679. Okay, and the second tweet is very long, so there are a lot of this list is very long, and this is the third tweet, this is the fourth, and so on. Okay, now it seems it's working now. Yes, now we have to create a variable name because we will use this transformed version of the tweets, right? Let's create a, for example, a new variable, new tweets, for example. Now we are talking about our training set, and let's assign the results of this tokenizer, this transformation, into our new tweets, right? Yes. Let's see the first output of these new tweets. Yes, as you can see, we got the first result. I didn't feel humiliated. It is represented by these four numbers. Okay, and let's do. Is there any question to this point, Nikolai?
Yes, it seems like it works.
Yes.
With the right function.
Yes, it works now. It was my mistake without transfitting the data. I tried to transform it. It's impossible, as you can see. Yes. I hope yes, we will do the same operations for our validation set, right? Because we have to also transform the twists into numbers for our validation. Validation twists are represented wall twists, as far as I remember. These are our validation data, and we will use the same tokenizer. It already fitted the data, so I don't need to fit for the again. So instead of tweets, I will use validation tweets. Maybe I can use validation tweets in the future. So I will use validation tweets 2. Let's say 2. Okay. So we don't need to every time. Sometimes we need to read the actual text. So I'm creating. Yes, this is the output of this transformation. For example, this is the first tweet of our validation data set, right? Now we are ready to dealing with the text or tweets of our training data set and validation data set. The next step is to dealing with the labels, right? As you know, the labels is also represented by words as sadness or love, something else. So we have to deal with these ones. But first we have to learn how many labels we have. Let's see this one. I think by visualization we will understand better. Matplotlib.pyplot splt, and in order to get a good visualization, let's import Seaborn as SNS. Let's run this code line, and I import SNS because I want to get a good style, set style. This will use a good style. Let's use dark grid. It will create a background inside our visualization. That's not dark grid, but dark grid. Yes, and after that, let's create our let's create a histogram, which means a distribution plot for our labels. Right? This is the labels of our training data set. As you can see, 1, 2, 3, 4, 5, 6. There are 6 labels has been assigned for the tweets, right? We can make the figure a little bit bigger. Figure thick size is equal. Um, yes. Now we will get a bigger version of the figure. As you can see, sadness. We also see the number of each element. For example, more than 4,000 tweets has been labeled as sadness, and anger almost 2,000, love 1,000, surprise maybe 500, and fear and joy and more than 5,000, right? So we understand that we are just 6 labels for our labeling the tweets, right? Um, Therefore, it means we can transform these labels, okay, into the numbers. We have used this function before. From Cyclone, we will use label and encoder. We have used for this one for mushroom data also. It's very useful labeling, transforming words into the or strings into the numbers. Cyclone from preprocessing. Yes, import label encoder, label encoder. After importing function, the first step is creating an instance or an object. Okay, let's give a short name, LA, label encounter, label encounter. Now we have created object, which means that after creating object, this by using this LL short version, we can use every method inside this function, right? The method is simple, library, and after that, function. Inside function, we can use the methods we have. Now, now we will label LA dot fit transform method, as you can remember maybe from previous tutorials. Um, we will assign, this will fit our labels and transform them into the numbers, right? Let's assign the result into our new labels, because for labels, maybe labels too, we can use labels too. Maybe we need in the future for the string version of the labels, because after this transformation we will get the numbers, not the strings. So yes, this is an array. It has transformed every label, sadness, love, joy, or something else, into the numbers. From beginning 0, I think the last one is the 5, label 5. Okay, so we have to do the same thing for our validation labels. Okay, so let's just copy this code and paste here. Instead of if I remember correctly, one labels, uh, one labels, we have assigned one validation labels. Yes, if it is not true, okay, one labels 2. Let's assign this one labels 2. When we are using this label encounter or something else, we don't need to fit again. Just transform is enough, because this object has already fitted our data. It also get knowledge of the tweets. It also assigned these labels. So when when this one, when it comes to validation labels, when it encounter, for example, sadness, it will automatically assign the same value, corresponding value. For example, if sadness has been labeled as 4 from this previous fit transform, it will assign 4 for the other whenever we use this function. Okay. Okay. Yeah, I I remember correctly. Interesting. Yes, validation labels. So let's use, in order to remember correctly, let's check this one. Not two. Let's see the original ones, right? As you can see, uh, I think sadness has been labeled as 0. As you can see, 4, I'm sorry, 4, 4, and 3. So love has been labeled as 3, as you can see. And anger, and is coming next, but we cannot see now. It's a very long NumPy array, maybe more than thousands of labels. Um, yes. Um, the next step is, oh my God. Does it seem difficult, Nikolai? What's your opinion?
I think it's okay. It might be a little difficult with regards to it being unfamiliar and so new to most people.
Yes, but to be sure, I try to provide the simplest version of the code. Normally, when you go to the, for example, Kaggle, and you can encounter very hard code. So it's very it's very uneasy to encounter such difficult codes. I try to simplify it uh, in order to make you understand easily. But as you said, when you encounter one time more, one time more, one time more, and after that your brain will accept, and you will get used to the code. So it becomes very easy. And after that, yeah, it's also valid for everything we learn new. So this is the good starting point, I think. And so we have now a problem. The problem is, uh, as you can see, let's see, for example, tweets, the original tweets, right? Um, every tweet has a different size, right? This, for example, includes 4 words. Someone else equals more than 4 words, maybe 50 words, right? So when we create our model, we have to create the same size. How can we do that? We will import another function, but in order to simplify it, for example, this first tweet is represented numbers, 4 numbers, right? But this one includes more than 4 numbers, maybe 12 numbers. But after that, it will add numbers but zeros in order to match the same size for every tweet. For example, after the fourth one, because we have 4 words for this tweet, there will be zeros that will, in order to make them in the same size for the algorithm. Okay, so it's not important for the algorithm, but the size of the tweets or the words is important. For this purpose, we will use from TensorFlow.keras. Okay, previously Keras and TensorFlow was separated libraries, but TensorFlow 2, after TensorFlow 2, we can see in the same library, main library, and sequence, inside sequence, import path sequence, which means it will path all the sequence in the same size. Okay, therefore we import this function. Okay, I run this code. Yes. Um, let's see. For example, let's use this one. You will understand better, I think. Um, let's see. For example, our new tweets, right? If I remember correctly, as you can see, uh, if the tweets, for example, all the TVs has been at the same size, has been sized in the same length. Okay, according to the longest tweet has assigned the size of the entire tweets, but if some tweets has minor than the same word, this path sequences has assigned 0. So it will not affect mathematical calculation for the recurrent neural network. Yes. Let's see the shape of this one. As you can see, now all the tweets, if you remember, the first tweets just only has the size of 4. 4 words has been represented for numbers. But we understand here that the longest tweet has 66 words. So all the tweets has been resized by adding zeros after that in order to match the same size of the tweets. Okay, this is the path sequence function does for us. And so after this one, let's assign this one for our new tweet 2. There have been many new tweets, but let's do this. Let's copy this one because we will use it. We will use the same function. But truncating, this will add if, for example, a word has not the same length, it will add zeros. This truncating parameter will add zeros for this one, and I can only assign post or pro because it will assign at the end of the lower tweets. So I am using post. And there's another one, padding. Padding means if a tweet has a missing value for its previous words. For example, someone has been used tab and after that begin to write the words, right? So in the first words will be missing. So this padding will add zeros for this kind of problem. So let's see this one post. Yes. Also, we can also use maximum length parameter. Uh, in order, we don't have enough time. I have gone through all of these tweets, but the majority of the tweets is lower than 60, maybe 99%. So as you can see, there are 2 or 3 tweets that has been higher than 60 words. So I will say that please cut if the tweet is longer than 60 words. I don't need that. There is only 2 tweets, so I don't want to these 2 tweets affect my machine learning algorithm so much. So therefore, I am designing a limit for the length of the length of the tweet, or length of the words of the tweet, we can say. Let's see these new tweets. Now we are dealing with our training data set, right? As you can see, these are the new tweets, these transformed tweets, and let's see the shape of it. And as you can see now, the shape has been assigned 60, right? We have 16,000 rows, but these are number of columns which represent the number of the words inside for every tweet. But because we designed a limit for the length of the tweet, now the shape has been lowered from 60 66 to 60. Okay, we will do the same operation for the also validation tweets, because we will use, when we train our algorithm, we will use also validation tweets. Okay, let's name this one validation tweet 2. Validation tweet 2. Instead of new tweets, we will use the latest version of the validation tweets. Okay, but as far as I remember, we assigned val 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 tweet 2. I think we will do the same operation. Yes, instead of, let's do this one. Yes, I remember correctly. Interesting. Yes, this is a transformed version of the validation tweets. If you want to see this one, let's see it. Validation tweets 2. Yes, these are validation tweets. As you can see, the size of the tweets differs from tweets to tweets. Now, after these path sequences, we have resized every single tweets according to the size of the maximum size of the tweet. Okay, so yes, this is very good for the algorithm. We don't need that. Just I added this one to show you the difference. Yes. Now we have arrays. Let's see our labels, right? Labels. What kind of stuff? In order to use machine learning algorithm, we always labels 2. Maybe. Yes, we always need numpy arrays, right? Therefore, I am checking it is an array or not. Yes, it seems it's an array, no problem. We can, for example, we can do labels 2. We can create a numpy array if it was not an array. Numpy array labels 2, and this is a very good, a common way to transforming a normal Python list into numpy array, right? Let's do the same thing for validation data labels. Validation labels. Val labels 2. Val labels 2. Let's find this one. That one is not. I am not remembering correctly. Yes, validation. It's val labels 2. Val labels 2. We have all my. We need here val labels 2. Yes, as you can see. Oh my God. We can. There is a problem because I use normal validation tweets, so we reassign the words into our validation labels. We have to correct this one. We can maybe, Nikolai, take a 1 minute or 2 minute break, and because I want to arrange this problem, get that one ready. 1 or 2 minutes, maybe a couple of drink as a water or something like that. 2 minutes. I will run all of them, and after I'm running, it will be all right. Now we are ready, almost ready. Just, yes, of course, now it's ready. Now we reassigned label, validation labels too. Now all of the tweets is a numpy array. Also, all of the labels are numpy array. No problem for that, which means that now we can train our algorithm. This is the latest part. Um, for creating deep learning algorithms, we are using TensorFlow main library .keras .models, which includes all of the deep learning models. Import sequential model because we will create a sequential recurrent neural network line, right? We are also using this sequential for artificial neural networks because it's also a sequential line. So we are using, this is our main model, and yes, and after that, this is not enough for us. We will also, let's copy here instead of writing every time. Now we have to add layers, right? Layers, import. I will explain what these layers means. Embedding, also from TensorFlow.layers, import dense. Dense is mainly used for normal artificial neural networks, but as I said before, recurrent neural network also includes artificial neural network. Therefore, we use dense layer also from TensorFlow. Why I'm copying the same thing again, and layers import LSTM. This is the main part. As I told, it's very important for training recurrent neural networks. Yes,